What if I told you that some exit signs glow without electricity? What if I told you that doctors can see inside the human body without cutting it open? And what if I told you that all of this is possible because of tiny changes inside atoms? These atoms are called isotopes. They are invisible, they are everywhere, and they quietly power medicine, science, safety, and modern technology. In this video, I'm going to clearly explain how isotopes exist, how they behave, and how humans learn to use them in a way that actually makes sense. What an isotope really is. Every atom has a nucleus, and inside that nucleus are protons and neutrons. Protons determine what element an atom is. Neutrons determine which isotope of that element it is. So if you change the number of neutrons in an atom, you do not change the element. You only change the version of that element. That version is called an isotope. Isotopes are atoms of the same element with the same number of protons, but different numbers of neutrons. This small nuclear difference leads to very big consequences. Hydrogen. The simplest example. Hydrogen is the simplest atom in the universe and the best example of isotopes. All hydrogen atoms have one proton, but they can have different numbers of neutrons. Hydrogen 1, also called protium, has no neutrons. Hydrogen 2, called deuterium, has one neutron. Hydrogen 3, called tritium, has 2 neutrons. All three are hydrogen. They behave like hydrogen chemically, but their nuclei behave very differently. And this is where isotopes become useful. How isotopes come into existence. Isotopes exist through 3 major processes. First, inside stars. In stars, nuclear reactions constantly create and modify atoms by adding or rearranging neutrons. When stars explode, they spread isotopes across the universe. The atoms in your body were once formed in stars. Second, naturally on Earth. Some isotopes are naturally stable, while others are unstable. Unstable nuclei are unbalanced and eventually release energy to become stable. This process is called radioactive decay. Third, artificially by humans. In nuclear reactors and laboratories, scientists deliberately bombard atoms with particles, forcing them to gain or lose neutrons. This is how many medical and industrial isotopes are produced. Why some isotopes emit radiation. An unstable nucleus cannot remain unstable forever. To reach stability, it releases excess energy. This energy is emitted as alpha particles, beta particles, or gamma rays. This process is not random. It follows strict physical laws. Radiation itself is not evil. The danger comes from uncontrolled or excessive exposure. When radiation is controlled, it becomes one of the most powerful tools in science and medicine. Tritium,